It's Wednesday, June 1st. My name's Juan Brown. You're watching the Blanco Lirio channel, and we have the final report out from the Cessna Citation crash in Oroville, California that happened way back on 8/21 of 2019. First covered on this channel on the 21st of August, 2019. This accident report is important because there was a second accident. This first accident did not involve any fatalities, though the aircraft was destroyed in a post-crash fire. But there was a second accident on September 2nd, 2021, about a year later, under similar circumstances that did involve 4 fatalities. Lawsuits are occurring on this accident, and we have yet to get the final report out for the Farmington, Connecticut accident report. But the conditions are very similar to what happened in Oroville. Let's check it out. First off, the reason these reports take so long is they're so extremely detailed. We've got hundreds of pages of documentation here, and a lot of this comes from third-party sources, which the NTSB has to wait for to receive. But out of all these hundreds of pages of data, we can get the overall analysis and summary right here. The crew was conducting, first of all, this accident occurred in Oroville, California, August 21st, 2019. It's a Cessna 560XL model of Cessna Citation. It was a runway excursion. It was conducted under Part 135, FAR Part 135, as a air taxi commuter. People were paying for a flight on this aircraft, November 9-1 Gulf Yankee. No injuries out of 10 people. The crew was conducting an on-demand charter flight with 8 passengers on board, 8 passengers, 2 crew members, as the flight taxied the airplane to the departure runway. The co-pilot called air traffic control using his mobile phone to obtain the departure clearance and release. That's because Oroville Airport is a non-controlled airport. It's a Unicom frequency. There is no tower at Oroville, so they got to use the cell phone to get an IFR clearance up out of Oroville before they take off. Distraction number 1. According to the pilot, while continuing to taxi, he stopped the aircraft short of the runway where he performed a rudder bias check. More on that in a moment. It's the last item in the taxi checklist, and applied the parking brake without verbalizing the parking brake or rudder bias actions because the co-pilot was on the phone trying to obtain the IFR clearance. Normally, these are things that you communicate clearly with each other crew member. After the pilot lined up on the runway and shortly before takeoff, the crew discussed and corrected a no takeoff enunciation for an unsafe trim setting. The Cessna Citation has a takeoff warning system that includes, one of the things included in that takeoff warning system is a trim out of position. You need your elevator trim set to the correct position for takeoff to prevent excessive force on the yoke for rotating and taking off. After the co-pilot confirmed takeoff power was set, he stated that by the way, they got that fixed. They got the light to go out and they pressed on. After the co-pilot confirmed takeoff power was set, he stated the airplane was barely moving, then said that something was not right. That's the co-pilot. To which the pilot replied, the airplane was rolling and to call the airspeeds. Human factors. On the right side, we've got a co-pilot that just senses something is not right. And on the captain's side, he's saying full steam ahead, press on. About 16 seconds later, the pilot indicated that the airplane was using more runway than expected, then made call-outs for takeoff decision speed and rotation speed. They did obtain V1 rotate speed on this takeoff, though way down the runway. The pilot stated that he pulled the yoke back twice, but the airplane did not lift off. Shortly after, the pilot applied full thrust reversers and maximum braking. Then the airplane exited the departure end of the runway, impacted a ditch, and came to a rest 1,990 feet beyond the departure end of the runway. The airplane was destroyed by a post-crash fire, and the crew and passengers were not injured. Post-accident examination on the airplane and computed tomography scanning of the parking brake valve revealed that it was in the on position at the time of the accident. Calculations based on aircraft performance data and airport surveillance video indicated the accident aircraft was able to accelerate to the speed required for the airplane to rotate and lift off as configured for a normal takeoff. However, the airplane's performance was substantially degraded during the accident takeoff roll by the unexpected retarding force acting on the wheel runway surface. Based on the parking brake valve examination and the performance of the airplane during the accident sequence, it is likely that the engaged parking brake produced the unexpected retarding force at the wheel runway interface and at a magnitude and direction that adversely affected the airplane's acceleration rotation capability during the attempted takeoff. In other words, the parking brake was set, and even though, and we'll get into this in detail, even though the aircraft was able to accelerate to takeoff speed, when you go to rotate, the force of the parking brake overcomes the force of the elevator. The aircraft will not rotate. The brakes will just keep the nose on the ground. And so you go to rotate and nothing happens. Review of the CE 560XL parking brakes certification. And this is a situation that goes all the way back to the certification of this particular make and model of Cessna Citation, which has been changed in subsequent models. Revealed that the parking brake was designed to prevent the airplane from rolling if one engine is at takeoff power and did not require a cockpit indication if the parking brake was not fully released. In this make and model of Citation, the parking brake is not a part of the takeoff warning system, as is common to most all other aircraft. The head of the training, where the pilot and co-pilot received their training, stated that no airplane flight manual, checklist, or training curriculum provided a caution or warning that takeoff speeds may be achievable with full or partial pressure applied by the parking brake, and the pilot reported that he expected the airplane not to move with takeoff power applied. That's what you would expect as a pilot. You'd think that, well, if the parking brake's set, the plane's not going to move. Well, under certification, they only certified it to hold the aircraft with one engine up to takeoff power setting. If you put both engines up to takeoff power setting, they will overpower the parking brake and you will roll down the runway. Available evidence, including continuous heavy deposits on the runway consistent with the main landing gear wheel spacing throughout the acceleration segment of the takeoff roll, indicates that it was likely that the pilot did not release the parking brake after setting it to perform the rudder bias check. That was the last checklist item on the before takeoff checklist. Because the parking brake knob was located on the pilot's left side and was obstructed from the co-pilot's view, it is unlikely that the co-pilot could have seen the pull knob before or during the takeoff. Although the crew was aware of the plane's slow acceleration, it was not clear at the time that it was related to the unexpected retarding force of the unsafe condition of the engaged parking brake. Had the parking brake lever been incorporated into the condition that trigger a no takeoff annunciation, as required for airplanes certified after 2002, the pilot and co-pilot likely would have identified that parking brake remained engaged and corrected the unsafe setting before attempting the takeoff, just as they did for the unsafe trim setting. So if the parking brake design, certification design, had been part of the takeoff warning system, they would have been able to capture their error earlier. The crew. Despite the flight crew's non-adherence to standard operating procedures, a checklist item that directed the pilot to fully release the parking brake before takeoff could have also served as an important redundancy to the annunciation, but none appears in the before takeoff checklist. We'll take a look at that. The checklist only references brakes. It says nothing about parking brake. Probable cause and findings. The NTSB determines the probable cause to be the pilot's failure to release the parking brake before attempting to initiate the takeoff, which produced an unexpected retarding force on the airplane nose-down pitching moment. Also causal was the flight crew's delayed decision to abort the takeoff. They were late to make that decision, late to capture their error, which resulted in a runway excursion. Contributing to the accident was the lack of a no takeoff annunciation warning that the parking brake was engaged, and lack of checklist item to ensure the parking brake was fully released immediately before takeoff. Let's take a closer look at this. Now we'll go through some of the pictures in the report here. These are examples. This is not of the actual accident aircraft, but here's the parking brake handle, just a simple plunger, typical parking brake. You press on the toe brakes and then pull the parking brake out to set it. But this parking brake is under the dash right here, and it's kind of obscured from view visually by the captain's yoke. Here's the departure runway, runway 02 out of Oroville, nearly 6,000 feet long, and they indicate tire marks pretty much down the entire runway length. Here's the departure end of runway 2, where the aircraft finally came to a stop and was involved in a post-crash fire. I think that post-crash fire was caused by the right engine did not shut down immediately, continued to run, and since the gear was wiped out, the aircraft was on its belly, the exhaust from that right engine set the grass on fire, which in turn ended up destroying the airplane, but not before everybody was able to safely get out. And in this report, you'll see the FO had to kind of kick that door open. It was reluctant, in his words, to open up. He had to kick that door open and was able to safely get everybody out before the aircraft was destroyed. Now, here's the picture of the parking valve, the actual parking valve, with the parking brake valve control lever in the on position from the actual accident aircraft. And of course, they did all the data to find out just how slow this aircraft rolled down the runway, but was able to obtain V1 takeoff safety speeds eventually. Here's some more pictures of the accident aircraft destroyed in the post-crash fire. November 9-1 Gulf Yankee. By the way, this has since been extended at the Oroville Airport. This is now a paved section of overrun running out of here. If we go to look at Google Maps now, the aircraft ended up right about over here. This section of overrun at Oroville is now paved. At the time of the accident, the overrun terminated here at about runway 13 intersection. Part of the details in these reports are the pilot's handwritten notes as to what happened right after the accident to the NTSB. And the point I want to make here is that when you witness an accident or are a part of an accident situation, what you see and remember from the accident doesn't necessarily always add up to what actually happened. If you've got the videotape evidence, the audio recording evidence of the accident, you'll be surprised how different what your mind remembers as to what happened versus the actual facts of what happened. And this is just human nature. It happens to all of us. So when you make these statements, it's going to be long before you get to review the tape, so to speak, of the cockpit voice recorder, because they got to recover that recorder and download the data and save it. And in this data, in this cockpit voice recorder, you can tell exactly what went on here. And it reminds all of us to, you never know when something's going to happen, and to keep your conversations professional, especially in the below 10,000 feet on the ground operations, critical phases of flight. You just never know when it's going to come up in one of these accident reports. So this transcript picks it up from taxi out all the way out to the end of the runway. There's a problem with the elevator trim being in correct setting, and there was a problem too with the iPads jamming up in the control columns where they should be put in such a way that they are not to interfere with the control columns. So they talk about that. They fix all that. Then they have the distraction of the co-pilot going on to the telephone to get his IFR clearance. And then if we finally get the takeoff sequence started here at 11:30, 46.9 or 45.6. Got it? Ready. Yep. Oroville traffic, Cessna 9-1 Gulf Yankee is an active runway 2 departure jet card. Don't know quite what that means. Sounds of RPM increasing. Set takeoff thrust, takeoff set. Shit, she's barely moving. HOT2, this is the headset from the co-pilot's headset. Audio from the co-pilot's headset is HOT2. HOT2 HOT1 is the pilot's. So the captain says, set takeoff thrust. Co-pilot says, takeoff set. Co-pilot says, shit, she's barely moving, dude. Something ain't right, dude. And this is within, 5 seconds of setting the power. And here's the captain saying, she's rolling, call the speeds. So that was their last chance to really trap these errors. The FO was trying to tell the captain that something's not right, but the captain wasn't listening. He was just going to go. All right. Sound similar to a nervous chuckle from the co-pilot. And again, he says, dude. Now, this is where professionalism comes into play. The correct call is not dude or something ain't right. The correct call is reject. Reject the takeoff. We always brief that on the airlines. Just say the word reject and we'll sort it out later as to what the problem is. 80, cross-check panel clear from the co-pilot. Pilot, roger. Co-pilot, shit. Pilot, she's taking some runway. Co-pilot, V1. Pilot, roger. Co-pilot, rotate. Pilot, rotate. God dang. That's the co-pilot. Sound of 4 aural chimes. Some more swearing. Pilot says, well, and then the sound of decrease in engine RPM. We're now up to 1131.38 on the timeline. More swearing, cut it off. Finally, somebody calls out abort long after the abort's already been initiated. That is, the co-pilot calls abort long after the abort's already been initiated. Captain, it's off. Captain, evacuate. Co-pilot, yep. Sounds similar to a door opening. Right engine fire. Engine still running. The co-pilot's telling the captain that the right engine is still running. The captain says, yeah, that's why I'm shutting them off. End of recording. Part of an accident investigation is to rule out all other possibilities. They do the weight and balance for this accident, and they find that they are spot on for their CG and weight and balance. Here's the runway diagram for Oroville showing where they were parked and taxied out across runway 3113 down the taxiway to runway 02 for departure. Here's a picture showing where the EFBs, better known as your iPads, should be placed. All of your charts nowadays are done via the iPads, no more paper Jepson charts. And so these charts are either supposed to be, I suspect this is a piece of Velcro beside your seats and or these seat pockets right here so that they're out of the way of the controls. It sounded like when they were doing their before takeoff checks, these guys had these iPads out on their knees or in their hands, and they were interfering with the flight controls at the time. Another distraction. Here's another picture of the takeoff or the annunciator panel, and the takeoff warning annunciator is this one small light up here in the annunciator panel, no takeoff, which in this particular make and model does not include a warning for the parking brake being set, unlike later models or models sold overseas even. So it's here on the taxi checklist. I might have said before takeoff checklist. If I did, that was an error earlier. On this taxi checklist that you check the rudder bias system. This is the part of the checklist. It's checked by the pilot flying. This is the part of the checklist where this pilot flying elected to set the parking brake to do this test. What is the rudder bias system and its test? Most aircraft, let's find it right here. Most multi-engine aircraft have some sort of way of augmenting the rudder, biasing the rudder for an asymmetric situation like an engine failure. In the Cessna Citation, if you lose an engine, the rudder will bias you in favor of the good engine to help you maintain directional control of the aircraft using this rudder bias system. And on your taxi checklist, you need to check it. And so in order to check this system, you have the aircraft stopped, you have it out of the way of other aircraft because you're going to increase the throttle quite a bit. But it does not say on the checklist to set the parking brake. This is why I don't like messing with the parking brake. Personally, I only like to use the parking brake to keep the aircraft from rolling once it is parked and it's shut down. once I'm moving the aircraft around on the ramp, or especially the runway, I rarely ever like to use the parking brake, because I want to be able to just hold the brakes with my own feet and be able to quickly move the aircraft if I need to get out of the way of something. But in this case, the pilot elected to set the parking brake to do this test. So you advance the left throttle to approximately 60% N1, verify the left rudder pedal moves forward. Left throttle, left rudder, and that's a call out to each other. Remember, in this case, the other pilot, the co-pilot, was on the phone getting his IFR release. So the pilot flying just did this on his own. Then you advance the right throttle to approximately 60% N1. Verify the right rudder pedal moves forward. Right throttle, right rudder. Dead foot, dead engine, right? So as you increase the individual power asymmetrically on the Citation, you should feel a movement in the rudders that is assisting you in that asymmetric situation. And it's done through bleed air through the system on the Cessna Citation. Other aircraft have other systems that do similar functions. Once the captain, who was the pilot flying, completed this taxi checklist, he failed to release the parking brake, and that error failed to be captured by the co-pilot not flying because he was distracted on the phone, and it's not enunciated on the takeoff warning enunciator panel, and he cannot see the condition of the parking brake lever from his seat in the aircraft. So now you can begin to see how all the little holes in the Swiss cheese align all the way back from aircraft certification years ago to a little bit of a distraction, a little bit of non-standard procedure, and a little bit of late capturing of errors that led to this accident. Thanks so much for your support of this channel, especially the folks over on Patreon that make this content possible. See you here.